Good day to one and all. Today we will discuss about the formation of bus admittance matrix using direct inspection method. We know that V bus is equal to I bus into Z bus, where V bus is bus voltages, I bus is bus currents, and Z bus is bus impedance matrix. And we can write this equation in another form like I bus is equal to what is I bus? So I bus is bus current matrix is equal to Y bus Y bus is bus admittance matrix into V bus. So V bus is bus voltage matrix. So now we can highlight this equation. I bus is equal to Y bus into V bus. So this equation can be written as I1, I2, I3 up to nth bus. So we are expanding this equation up to n buses. So now we wrote the bus current matrix I bus. So I1 is the first bus current value, and I2 is the second bus current value, and I3 is the third bus current value, and up to we are doing up to nth bus current value. So I bus is equal to Y bus. So Y bus is the bus impedance matrix which we have to form. So we are expanding it. So Y11. So admittance between the bus number 1 to bus number 1, and Y12 bus admittance matrix between 1 and 2, and Y13 admittance value between 1 and bus 1 and bus 3. So we are expanding up to nth bus. Into V1, V2, V3 up to V1, Vn, where V1 is the bus voltage value at bus 1, and V2 is the bus voltage value at bus 2, and up to Vn, nth bus voltage. So particularly we are interested in the bus admittance matrix Y bus. So now through direct inspection method, we will form the Y bus. So this Y bus matrix consists of two types of elements. You can see in this matrix form. So there are two types of elements. One is diagonal elements. You can see here I marked it here. So these y11, y1, y22, y33 up to yn are called as diagonal elements. Whereas the rest of the elements like mutual admittance values are the non-diagonal elements. So like y12, y13, y21, y23, y31, y32, and yn1, yn2, and these things are non-diagonal elements. So these diagonal elements are formed by adding all connected branches admittances of the bus. So if we take bus number one, so which are the branches, which are the branch admittance are connected to it, so they must be added. So like this, we can form the diagonal elements. Whereas to form the non-diagonal elements, and non-diagonal elements formed by taking negative values of admittances. So by these two steps or two rules, we can form entire bus admittance matrix, or sometimes it's called as Y bus. So now we solve this problem, a simple three bus power system, by using direct inspection method. Here they given three admittance values of three branches, and it consists of three branches and three bus system. So one branch is between 1 and 2. So the impedance value of bus number 1 and 2 is J 0.4, and if you want to make it into the admittance value y12, so 1 by j12, so it is 1 by j 0.4, which means minus j 2.5. Similarly, there is another branch, one bus number 1 to bus number 3. So the impedance value between bus number 1 and 3 is J 0.3, and if you want to find the value of impedance value of bus number 1 and 3, y13 is equal to 1 divided by J13, which means 1 by J 0.3, and this give value around minus J 3.33. Similarly, we have another branch from bus number 2 to 3. So the impedance value between the bus number 2 and 3 is J0.2, which means we have to find the value of Y23, which is the impedance value between bus number 2 and 3 is equal to 1 by Z23. So 1 divided by J0.2. So which means minus J5. Now we have all the mutual admittance values here like Y12, Y13 and Y23. It is very easy to form bus admittance matrix using direct inspection method. So we already know that Y bus is the Y bus is bus admittance matrix. Bus admittance matrix. So if we expand the Y bus Y11, so 3 into 3 matrix because we have three bus system. So Y bus should be 3 into 3 matrix. So Y11, Y12, Y13, Y21, Y22, Y23, Y31, Y32, and Y33. Here, so there are two types of elements. So one is diagonal elements like Y11, Y22, Y33, and the rest of the values are non-diagonal elements. So the rest of the elements are non-diagonal elements like Y12, Y13, Y21, Y23, Y31, and Y32. First, we calculate diagonal elements. So Y11, so which are the branches are nearer to the Y first bus? So one is Y12 and another one is Y13. So Y11 is equal to Y12 plus Y13. Now we have already have the values of Y12 and Y13. So we have to substitute these values. So after substituting these values, we will get the values of Y11 value and Y22 value and similarly Y33 value. So now we have to calculate the values of non-diagonal elements. So Y12 is equal to, and Y12 and Y21 are identical. So minus of Y12. So we will get around J 2.5. Similarly, Y13 is identical to Y31. The formula given is minus Y13, and the answer is J 3.33. Similarly, Y23 is identical to Y32, and we will get the value of Y23, and Y32 is equal to J 5.0. Now we will arrange these values and form the Y bus. So Y11 is minus J 5.833 or 83. Similarly, Y12 is equal to J 2.5, and Y13 is equal to J 3.33. We know that Y21 is identical to Y12, so J 2.5, and Y22 is equal to minus J 7.5, and Y23 value is equal to J 5.0. And we know that Y13 is identical to Y31, so we just dump the same value, and similarly Y23 value is equal to Y32 value, so both are identical, so we can put J 5.0, and Y33 value is minus J 8.33. So like this we formed the bus admittance matrix of a 3 bus system, and now we will solve this same problem in Matlab software. First, we will write CLC and clear all. So first we have to give the line data value. So line data value is the branches information, and what is the value of impedance values. So R and X values. So branch 1 and 2. So the branch between bus number 1 and 2 is R value is 0 and X value is 0.4. Similarly, the bus number 2 and 3 branch R value is 0 and X value is 0.2. Similarly, the branches between 1 and 3 bus is R0, X is equal to 0.3. So now we have to give the value of J value. So J is equal to square root of -1. So also we have to give the value of, we have to give the information about the first line of the column, line data column. So this is the number of length of the bus, and R value, similarly R value, and reactance value of line data. So it represents the column of the line data. So number of branches, first we have to calculate how many number of branches are there. So the maximum number of line data column 1. So it is obviously we will get 1, 2, 3. So NBR is equal to 3 here. Similarly, we have to find the value of number of buses. So here number of buses is also 3. So we have to take the value of maximum value of NL and maximum value of NR. Then we will get the value of N bus. So we know that branch impedance is equal to R plus J X, and we have to find the value of branch admittance values. So y12 is equal to 1 by j12, y13 is equal to 1 by j13. So next we have to compute the off diagonal elements, which is mean non diagonal elements. Sir, but we are doing for the n bus system. So we are writing Matlab code for n bus system. So we are making a for loop here. So for k is equal to 1 semicolon NBR. So loop of, so we are writing for loop for n bus calculation. Now we will give the formula here. So y bus NL NR up to kth bus is equal to respect to negative value of the minus value of the admittance matrix. So we will compute the values like y12, y13, and y23 here. Similarly, we have to tell that y12 and y21 are identical, and y23 and y32 are identical. So for that we are writing a code here, and we should end the loop here, and then we have to compute the diagonal elements. Here also we are writing for the n bus calculation. So we have given n is equal to 1 is to n bus. We have to give the another loop for k value. So we will add the all branches which is connecting to the bus, and now we will run the code here. So after running the code, we get the same answer which we got in the which we solved previously. We solved the problem. So same answers we get in Matlab here also. So minus the y bus, we can see y bus here. So same answer we are getting. Y11 is equal to minus 5.833, and y12 is equal to 2.5 z, and y13 is equal to 3.333 z. Similarly, y21, y12 identical, y23, y32 identical, and y31, y13 identical, and finally y33 is equal to minus 8.33 I, all same.